Welcome to Data Science Made Easy. I am Divya Somakumar, and in this video, we are going to learn how to predict the NIFTY 50 using the LSTM model. Before we start with the model, let us understand what exactly is NIFTY. The NIFTY is the flagship benchmark of the National Stock Exchange, which is a well diversified index comprising top 50 companies in terms of free float market capitalization that are traded on the bourse. It is supposed to reflect the health of the listed universe of Indian companies and hence the broader economy in all market conditions. Now, let us start our LSTM model. Our LSTM model stands for long short term memory. It is a type of artificial recurrent neural network. The best part about LSTM model is that there is a feedback system. LSTM models can not only process single data points but also entire sequence of data such as speech, video, etc. Now, let us begin our LSTM model by first importing the necessary libraries. Import math, import pandas as PD, import numpy as NP from sklearn.preprocessing import min max scalar. Now, for making the LSTM model, we have to import the sequential model from the TensorFlow.keras. From TensorFlow.keras.model import sequential. Now we have to import the dense layer, the dropout layer, and the LSTM layer from TensorFlow.keras.layers import dense dropout LSTM import matplotlib.pyplot as plt plt.style 538. 538 style implies the style that we see on the graphs when we talk about stock exchanges. Those dashed lines which look like ice, those are the 538 kind of graphs. Now, let us run this. Now, all our modules are successfully imported. Now, we have to take care of our data. So, from where are we going to get the data? We are going to get the data from a library which is known as NIFTY50. So, we write pip install NIFTY50. Let's run this. It's going to take a while. So, we have successfully run the NIFTY library. Now we have to get the NIFTY code. So we write from NIFTY import get underscore history from date time import date. Now we are going to get our data is equals to get underscore history. The symbol for NIFTY50 is nothing but Nifty, all written in capital. Nifty enclosed within inverted commas, and our start date is equals to date. I'm going to take for the past 5 year data. So I will start from 2016, 15 September 2016. So 2016, comma 9, comma 15, and our end date I will take as 17th September 2021. End is equals to date 2021, comma 9, comma 17. And we'll write index is equals to true. So our data is in place. Now let's run this. Now let us look at the head of our data. So data dot head. So our data looks something like this. We have open, high, low, close, volume and turnover. Now we have to get the shape of our data. How do we do that? Very simple. We just have to write data dot shape and we get it. So we have around 1241 rows and we have 6 columns. Now let us visualize the closing price. How do we do that? We write PLT dot figure and we mention the figure size as fig size equals 16,8. PLT dot title, the title of our graph would be close price history. PLT dot plot. We are going to plot the close price. So we write data, then in the brackets we write close. Now our X label is the date and our Y label is the close price of Nifty. PLT dot X label date, comma font size. I'll give a font size of say 18. PLT dot Y label. What is our Y label? It is nothing but close price of Nifty, and we'll give a font size of 18. Font size is equals to 18. And I want this graph in my Jupyter notebook itself. So I will write plt.show. Now let us run this. So we have got a graph which looks like this. And why we mentioned 538 in the previous part, that was plt.style.use is 538, we get this kind of graph only because of the thing that we have written on the top. These type of graphs are a result of the 538. Now, the next thing that we have to do is we have to create a new data frame with only the close column. How do we do that? We write close is equals to data dot filter. We are going to filter and we only want the close column. So we write close and we are going to run this. Now we are going to convert this data frame into a NumPy array because it becomes easier to handle NumPy arrays. You can easily do your scaling on it. We can easily apply our LSTM models if we have NumPy arrays. So what do we do? It's an easy step. We just write dot values. Let's call it data set is equals to close dot values. Now, let us divide our data into training data and testing data. For the time being, we'll only deal with training data. So we write training underscore data underscore length is equals to math dot seal length of data set. This is the name of our data now, multiplied by 0.8. What does that mean? 80% of my data I am using it for training. Now let us see how this training data looks. Training underscore data underscore length. So we have in all 993 training data points. Now the next step is to scale this data. How do we do that? We will apply the min-max scaler on it. So we will first create an object for the min-max scaler. So scaler is equals to min-max scaler. I want all my numbers in the range from 0 to 1. So I will mention a feature range. Feature underscore range is equals to 0 comma 1. Now I'm going to fit this scalar onto all my data. So I'll write scaled underscore data is equals to scalar dot fit underscore transform. I'm going to transform my entire data set. Now let us run this. Now let us go on to create our training data set using the scale training data set. So first and foremost, we are going to use a part of the scale data as our training data. So we write train underscore data is equals to scaled underscore data. I want all the points up to the training underscore data underscore length underscore data underscore length, and I want all the columns. Now let us split our data into X train and Y train. Since we are dealing with time series data, we will not have a Y column. But here there would be a difference. Now, if you have say stock prices 110, 120, 130, 140, and the 140 that you have got, that price is dependent upon your 110, 120, 130. So your 110, 120, 130 becomes your X variable, that is your independent variable, and your 140 now becomes your dependent variable. So our X and Y is divided in a different sort when we deal with time series data. So now let us split our data into X train and Y train. So X underscore train, let's pass an empty list. Y underscore train, let's again pass an empty list equals empty. Now I want to find this X train and Y train. So I will write a loop for it for I in range 60 comma length of train underscore data colon X underscore train is equal dot append train underscore data I to 60 going up to I minus 60 going up to I comma 0 y underscore train equals dot append train underscore data I comma 0. Now if I less than equal to 61, then print x underscore train, print y underscore train, and print empty. Now let us run this. So we get an array of x train and y train. Now let us move on. Now we have to convert this array that we have got into NumPy array. How do we do that? Let's do it. Convert x underscore train, y underscore train to NumPy arrays. So we write x underscore train, y underscore train is equals to np dot array x underscore train, comma np dot array y underscore train. Now we have to reshape our data. The problem with LSTM is that it only works when you have a three-dimensional data. So we just write an extra one so that our dimension increases. So reshaping the data, x underscore train equals np dot reshape x underscore train, comma x underscore train dot shape. I want the first element of the shape that we get. So we have seen in shape of X train, it was 993. So I just want the first element of it. So I write 0 and then I want the second element of the X train underscore X underscore train X underscore train underscore shape. And I will give one more dimension to it, which is nothing but 1. So we have successfully reshaped our training data. Now let us check our x underscore train dot shape. X underscore train dot shape. So now we have a three-dimensional shape. We have 933, 60 and the 1. Now it is time to build our LSTM model. Now let us build our LSTM model. How do we do that? Model is equals to sequential. Now I'm going to add layers into it. Model dot add first layer is an LSTM layer. I have around 50 neurons in it. Return underscore sequences equals true. Now, why is return underscore sequences written as true? So that the second LSTM layer has the three-dimension sequence input. We write return underscore sequence is equal to true so that our second layer of LSTM has three-dimensional input. Now, let us write the input underscore shape. Input underscore shape equals x underscore train dot shape 1. We can write this manually also. We can write the shape manually, but there can be possibility that we make mistakes. So it is better to write x underscore train dot shape, the first index of x underscore train dot shape. That is, we want the 60 over here. That is why we have written this. Comma 1. Now let us add one more layer of LSTM. Model dot add LSTM 50 return underscore sequences equals. Now we'll write false over here because now I'm only going to add one more dense layer. I'm not going to add another LSTM. So I don't have to write return underscore sequence equals to true because there is no need to have the data in three-dimensional form anymore. Now let us add one dense layer. Model dot add dense. We'll put 25 neurons. Model dot add one more dense layer with one neuron. That is the final layer where you want your predictions to happen. Now let us run this and see what exactly we get. Now let us compile our model. How do we do that? We write model dot compile. We will give the optimizer as Adam because Adam has the power of two optimizers and it is an adaptive learning rate. So basically, when you're very far away from the minimum, you take a larger step as compared to when you are very close to the minimum. So optimizer is equals to Adam. And since this is a kind of regression, we have the loss function which is nothing but our mean squared error. So loss equals mean underscore squared underscore error. Now let's run this. Now we have to fit this model. So model dot fit x underscore train y underscore train batch size. You can give the batch size that you like. For simplicity, I'm just keeping it as 1. And epochs also I will restrict to 1. Now let us run this. So our loss is 0.0015, which is very good for us because our loss is pretty low. Now we have to create the testing data set. How do we do that? Test underscore data is equals to scaled underscore data. So all the data beyond your training data is your testing data. So you write training underscore data underscore length minus 60 till the end, and I need all the columns. Now let's run this. Now let us create our x underscore test. So let us create an empty list. Y underscore test equals data set training underscore length up to the end, and I need all the columns. Now the same way for training data, for test also we are going to create a for loop. For I in range 60 comma length of test underscore data x underscore test dot append. We are going to append into the empty list that we have passed test underscore data I minus 60, comma, going up to I, comma, 0. Now, let us convert this x underscore test into a numpy array. So we write x underscore test is equals to np dot array x underscore test. We are going to reshape this x underscore test into a three-dimensional data so that it can be easily passed into the LSTM model. So let's reshape it. X underscore test is equals to np dot reshape x underscore test, comma, x underscore test dot shape. I want the first element of the shape, comma, x underscore test dot shape. I want the second element of the shape, comma, 1. So now we are going to get a three-dimensional x test. Now let us do the prediction. Let's see whether our predicted values and our x test are similar to each other. So predictions is equals to model dot predict. This is our LSTM model, x underscore test. Now these predictions would be in the range of 0 to 1 because we have scaled this data. So we have to inverse scale this data so that we get the actual predictions. Predictions equals scalar dot inverse underscore transform. We are going to transform predictions. Now we have checked our predictions. It's the time to check for the accuracy of our model because there is no point in just making a model without its accuracy. We do not know how many times our model correctly predicts the NIFTY value. So we have to check for accuracy. We are going to check for R squared and we are going to check for root mean squared error. So let's do that. From sklearn dot metrics import r2 underscore score print, let's have an f string, accuracy r2 underscore score. We have predictions, the model's prediction, and our y underscore test. Now let us check for the root mean squared error. So RMSE is equals to np dot sqrt np dot mean predictions minus y underscore test squared. This is nothing but your root mean squared error. So now let us check for RMSE. So our accuracy is 89%. So 89% of the time our model has accurately predicted NIFTY and our RMSE is quite large, which is 381. Now we have to see the graph. We have to look at our training data, our validation data to see how our model has predicted. Now we are going to plot the graph. Train, we'll make train is equals to data. I want all the points till training underscore data underscore length. Validation or your test set is nothing but all the data after your training data. So valid is equals to data training underscore data underscore length. Now we have the predictions also. So we will put it into valid predictions equals predictions. Now let us visualize. So our train valid is in place. PLT dot figure. Let's give the fixed size as 16,8. PLT dot title. I will give it as Nifty. PLT dot X label. My X label will be date. I'll give a font size of 18. Font size equals 18. PLT dot Y label equals close price of Nifty. Let's give a font size of 18. Now we have to plot the close. PLT dot plot of the train. We will plot close. Now we have to see for our valid data or our predictions. PLT dot plot valid, or you can call it validation, close, comma, predictions. So what was your testing data and what were your predictions? Now, since we have training data, we have validation data, we have predictions, we will have to have a legend over here. So basically a legend is kind of a table which gives us the symbols which represent close, train and predictions so that it becomes easier for us to decipher the graph. PLT dot legend train val valid, it stands for valid, and predictions. So we have a graph which looks something like this. So your validation is your test set, and if you see a prediction, it is quite close to your validation set. And the blue lines that you see, those are your training data points. Now it is our next part that we have to deal with. Now, this is the model that we have created. We haven't yet predicted what will happen in the future. So, let's see how to predict what is going to happen tomorrow or in the future. So, now we have to repeat certain steps. So, first we have to get the data. So, we can actually cut copy paste from the top portion. So, from this part, we can actually copy paste it. So let's copy paste this, and instead of calling it data, let's call it Nifty underscore quote. Nifty underscore quote. Now let us run this. We are going to create a new data frame. Now this data frame will have the close data points. New underscore PF is equals to Nifty underscore quote close data. I'm going to use the past 60 days value to find out the Nifty future price. Now, let us first convert this into an array and then we will scale it. So, we are taking the last 60 values, so minus 60 towards the end. Now, we are going to scale this. Last underscore 60 underscore days, last underscore 60 underscore days underscore scale, because now we are using min max scalar, is equals to scalar dot equals scalar dot transform. So we are transforming last 60 days, last underscore 60 underscore days. Now let us run this. As we had done for X train X test, same thing we are going to do for this X test, wherein we only have the 60 days data. So let's write X underscore test. Let's pass an empty list. Now, what are we going to put inside this X underscore test? So basically this is underscore, not hash, X underscore test dot append. So we are going to append the last 60 days, which is scaled. Last underscore 60 underscore days underscore scaled. Let us convert this into a NumPy array. So we write X underscore test is equals to np dot array X underscore test. Now is the part where we were all awaiting. That is, we want to predict the price of Nifty for the next day. So let us do that. So let's say pred underscore price is equals to model, the LSTM model that we have created, dot pred. What are we predicting? We are predicting the X underscore test. Now our data is scaled. So it is important for us to apply inverse scaling so that we get the proper values. So pred underscore price is equals to scalar dot inverse dot transform pred underscore pred underscore price. So we are inverse transforming the pred underscore price. So we have got the predicted Nifty price as 17,248. Now you all can try with the different dates and check for yourself how this model works and try to make more improvements to the model so that the model improves its accuracy. I hope the LSTM model is clear for each and every one. Please do like, share, and subscribe to Data Science Made Easy. If you have any queries regarding LSTM or any other data science related topic, you can post it in the comment section below. Thanks for watching.